Hello, everyone. We're going to take a look at operating system facts. This is the beginning of the software section. Most of the software section is pretty easy. At the beginning, we talk about operating systems, and that has a few more advanced concepts in it. Let's get started. All right, so what is an operating system? The operating system is the piece of software, because it is a piece of software. We usually don't refer to it that way. When people say software, they usually mean Word or Chrome, something. However, this is a piece of software, operating system, and it provides the basis for what you want to do. The truth is the operating system is something that should be very functional, but also very out of the way. For most individuals, they don't really understand what the operating system is doing. For you, it's important to understand what it's doing, and hopefully you hunger for that. Hopefully you're hungry to know, what is this really doing? The reason why, because in IT, we have to know more about this so that we can help individuals that really their job is not to know what the operating system is doing. These facts, this information will be beneficial and helpful to you as you go out and troubleshoot. If you don't know how the operating system is organized and what it's really doing, which is really what our CMP 113 operating systems, or I believe the CIS 190 class is all about, is really the different operating systems. Windows, heavily on Windows, some Mac and some Linux. Because as this points out, when we're talking about desktops, laptops, servers, and that kind of thing, we're dealing with Microsoft Windows, Mac OS, and different versions of Linux. I will point out at this point, when you're talking about servers that run the internet, you're talking mainly about Linux. When you're talking about servers that run the internal systems for nearly every organization in the world, you're talking about Windows. And then Mac OS is a much smaller portion of any of that, and often is just on the desktops and laptops, not running on the servers, even though there is a possibility of that. The two most common operating systems for mobile devices are Android and iOS. Those are the two big dogs. And what is Android? Android is a version of Linux, heavily reliant on Java programming. And so you see that Linux there is also a huge part of the mobile side. What is iOS? Well, iOS is just actually Mac OS, which is actually just Unix. So these two are very closely tied together, even though their interface doesn't look the same, right? So an operating system basically is that computer program that allows people and hardware and software to interface with each other. Meaning, I want to use my printer. How can I use that printer? Well, that's through the operating system that happens. Way back in the olden days when I was really young, the software itself, the program itself, would deal directly with the hardware. And that began to be a real problem, because you could get some version of a word processor that actually wouldn't work with your printer. It really became one of those things that a lot of people were choosing WordPerfect because it worked with a ton of different printers. That's an interesting concept. We don't worry about that, because as long as it's compatible with the OS will take care of that. And that's what we're going to dig into. They also want you to know that anything that's got a computer has an operating system in it. And often, for instance, gaming consoles, televisions, smart cars, we call those embedded operating systems, meaning that you really can't change it. You can't really modify that. And so it's just meant to be what it is. It's embedded operating system. And that's put into what's called firmware. And that really brings out, well, what is firmware? We're using that where term again. And so hardware is something physical that you can put your hands on. Software is something that basically is not physical. You can't put your hands on, but it's usually what we're wanting to use. So the hardware makes the software work. And then firmware is right in between those two. It's basically software that's put into a piece of hardware, a chip, that contains the operating system in it, and it's not really upgradable. So when we talk about BIOS, or we talk about UEFI that's in the firmware, it's the same kind of concept. You have a TV and it boots up, and there's a certain portion of that TV that when it boots up, that it cannot change that. It's what it is. It's in the firmware. And then there's also a special type of software called a hypervisor. And that can be used to run multiple operating systems. Again, in the server class that I teach, it's all about virtualization, and you actually install ESXi on basically a server that's got a bunch of hard drives in it and a ton of processors and RAM. And this little tiny operating system basically plays the go-between between the hardware and all the other OSs that you install on top of it. And that's called a hypervisor. All right, so let's take a look at, digging into what is the operating system really providing for us, doing for us. Well, we have a graphical user interface. That's one thing that almost every, today's operating systems have, is a graphical user interface, also referred to as a GUI interface, meaning that you click on icons, you click on pictures, you click on different things like this. And most people don't even read it, right? That's notes. I know that. I don't need to see the little notes pop up for that. I know what it is. I know that's the calendar. Visual images are much quicker for us to digest in our mind and go, okay, that's what that is. And so we gravitated to that graphical user interface quickly and have not left it. However, all of the operating systems mentioned, except for those that are embedded, have a command line interface. And that is, basically the text-based interface. Load up the terminal here on this Mac. And there it is. There's a text-based interface that allows us to do a lot of the same kind of things we do in the graphical interface, except it's a lot more cryptic as to what you can do. You actually have to understand what to type in order to make it do what you're going to do. Yeah, go ahead and allow it. So this is just, giving me information on actually what's in the directory of desktop, which is where I went, and I listed that. That's all I did. So this is a command line interface, and most students today are not familiar with that. And I try to give you a ton of experience in that in the 113 class, because again, in networking, if you're going into any of the hacking stuff, any of the security stuff, command line interface is going to be part of your life. And for most technicians, it's a small portion. You don't usually have to go into the command line interface, but it's good to know how to use it. So as a matter of fact, when you get to do the Raspberry Pi, if you choose to do that project, you will be dealing with the command line interface. And it's a fantastic way to learn it, honestly, because it really gives you the opportunity to figure out what am I typing and why. It's really good. All right, so what does the operating system really provide for us? Well, it's an interface between the computer's hardware and the applications, so the software. It's kind of a middle layer. You've got your hardware, you've got your OS, and then you've got the applications that are running on top of that. And the operating system is going to take care of all that hardware for you so that you can just deal with the application. And for most people, again, that's what they do. They're concerned whether or not Word works, whether or not Chrome works. They're not really concerned about if Windows is working until Windows won't work, and then they're concerned. So it's the one that's, when they say interface, providing that data going back and forth. Now, when choosing application software, you need to know whether or not your computer is running a 32-bit processing on its CPU or if it's 64-bit. All computers can, if they're 64-bit, run 32-bit software. But if you have a 32-bit hardware, CPU, it's not going to be able to run 64-bit anything. So we're talking about backwards compatibility. And that still exists today. Almost every system is 64-bit. It's got 64-bit Windows or Mac OS or Linux running on it. And then what's basically happening is if the app is still 32-bit, it'll deal with that separately. It kind of goes into a dumbed down mode basically to make sure that it can look at that. All right, so we're going to take a look at that information a little more heavily in just a minute. But what you need to know is all major operating systems out there for desktop systems have versions. that are 32-bit or 64-bit. Disk management, of course, is a big deal. We have stuff we want to put and store. I have right here, this is a little M2 SSD, super fast SSD, and I have got gigs and gigs and gigs of family video and pictures on this. I also have this backed up, but there's a ton of information on this. Disk management is important. So much of the time, I've said this in another video, you really need to understand disk management. So many times people that are just starting, they don't understand disk management and it's confusing to them. Yet when they go and work with people, disk management is going to be a major portion of what they're doing because people need to store their data. They need to have that stored. We're probably 15, 20 years away from people just totally accepting the cloud as a way to do everything and never needing to know about storage anymore because it's just all stored for them. That's, to me, that's a scary thing, but for a lot of people, that'll be fine. And of course, disk management is how do we set up the storage space? What formats are we going to use and so on? Is it going to be NTFS? If it's going to be exFAT, all those different things. And then file management is all about using something like File Explorer on Windows or Finder on Mac or whatever the graphical user interface has for Linux, whether that's Dolphin or tons of different ones that are out there. And how do you deal with the files? Like, did I make the folder to put this in and did it move that folder to this place? All of that, file management. It also deals with process and memory management. Let me actually pull up here something on the Mac that I didn't think about. So what I didn't think about is showing you the different processes. So I'm going to come into Activity Monitor here. An Activity Monitor on the Mac is basically like Task Manager on Windows. And you can see what's using the most time, what's CPU time, actually what's using the CPU heavily. You can look at the system and what it's using in the user and what it's using. So this system is using 4.8% of the system resources. User, meaning applications I'm running, that's what that means. Me as the user running applications, using around 8%. And so this machine is idle about 88% of the time, which is normal. That's very normal. And when we look at all these different things that are happening here, it's like, wait a minute, I'm not running all this, right? I'm not the one doing this. There is hundreds, literally hundreds of processes running. And I am not running that many. I'm running Opera browser, I'm running Safari browser, I'm running Finder, I'm running presentation software here. That's about it. But we see here tons and tons. There's an Opera helper, so that would be me, right? But the dock itself, that's not me. That's the operating system that's doing that. And so they've got it divided out here so you can see that. And you can organize this by time or how many threads are being used or the GPU time or what processor ID it is, CPU percent. We can look at memory, how much memory is being used. So there's 16 gigs. Used is 11 gigs. So it's using quite a bit to get things done. We can take a look at who's using the most energy. Anyway, this is Activity Monitor. That's what it's called in Mac OS. And again, the same kind of stuff happens in Windows, and that's called Task Manager. So the operating system is handling the processes and managing the memory and how much memory is used and whether or not to use page file. In other words, a fake memory location that's on the hard drive. Basically, a page file is just a pretend memory. That's the way we get around limitations so that you could run way over 16 gigs if you wanted to on the system. And it would take a portion of the hard drive and basically make a page file and or a virtual memory space, as it's also called, and then use that like it's actually RAM. And what's doing it? The OS. The OS is taking care of all of that stuff. So it also manages the applications. to view, configure, and delete applications. Service management, the OS is also run services. Those are processes that run automatically in the background. The perfect example for this is all of your networking stuff, right? You got to be attached to the network. So we're going to run IP, Internet Protocol. We're going to run DHCP. We're going to run DNS. All these things that make your web browsing pleasing and easy to do. So those are all services. They're going to start up automatically, set themselves up automatically, and go about their life so that you can be happily on the internet. Device management, in other words, the mouse that's connected, what kind of printer do you have, what kind of keyboard do you use, all that stuff. And that device management is hugely important for making sure you can do everything you want to do, right? There's a device driver for your monitor. There's a device driver for your mouse, for your hard drive. And what we mean by device driver is that that's the piece of software that drives the device, that makes sure that that device is going to work properly. Wrong device driver, crashes and errors in dealing with the hardware. That's why a lot of times if usually where students see this is if they're running games on a PC and they've got a new updated driver for their GPU, for their NVIDIA or their AMD. You go download it and crazy stuff starts to happen, and then they have to roll back the driver or uninstall that to take it back to what it was before, because something in that driver software is not working right with the hardware, and then you have to wait till they fix it. Access control and protection, meaning who's got the privileges of actually getting into files and folders. This, of course, has become huge because when you think about the internet and getting viruses on your computer or Trojans on your computer, this is what's going to protect it or not, depending on what you set up for security, right? So an important operating system role is security. Important operating systems require users to log in with credentials before accessing sensitive information. This is a good time to point out, hey, I always, on all my computers, it doesn't matter if it's a Mac or Linux or a Windows machine, the first account you usually set up on any of those is going to be an administrator account because you need access and control to everything. But you don't want to stay that way. And so I'll always set up another account that's usually under my ID. And then that way, if a virus or a Trojan gets onto the computer, it does not have administrator privileges to run. Now, yes, you're hoping that your virus scanning software is going to catch it, but it's a lot safer if you're running just as a user. And that's really the standard on Microsoft. They really want you to go create a user account that's different from the first one. And then that way you have a way to administer the computer. You can type that in, you can log in as an administrator whenever you want, but you're not going to be running as an admin, so the virus or the Trojan doesn't also gain those same privileges. All right, so this is about the different operating systems, and you can take a look at that. Just flashing it on the screen is almost enough. I'm going to jump over. We're going to show this keynote, and we're going to talk about this 32 to 64-bit, which is an important concept that I've mentioned, and this is a little better information or more information than I've had before. All right, so 32 to 64. I think the best way to explain going from 32-bit to 64-bit is a graphic that shows it. 32-bit processing is basically like saying, I've got a couple of lanes here where the data comes in and out. And 64-bit processing is saying, okay, well, I'm going to actually double that. So when we went from 16-bit, so let's just really look at it as opposed to this little graphic, what really dumbs it down. We go back to 8-bit, that would be like saying the road is this big. It can fit 8 bits on that. And that's what the CPU can actually process is 8 bits at a time. Then we went to 16-bit, and now the road is twice as big. Then we went to 32-bit, and the road is twice as big as it was from 16 to 32. And then 64-bit. So you see that there's a huge difference in the pathway. Now, the other thing is that's also the biggest chunk of information that the processor can actually handle. It can handle this size of a chunk of data in one cycle, or it can handle this chunk of data in a cycle, right? Because we have that cycle that happens. So anyway, let's boil this down. The 32-bit number has 2 to the 32, or basically about 4 gigabytes worth of addresses. So we're dealing with memory at this point. A 64-bit number has the capacity of, wow, a lot, about 18 billion gigabytes, or if we convert it, about 16 exabytes in its address space. So when we're looking at pathways, that's about how much information, as they say, can I chunk at a time. I can chunk twice as much information as I used to be able to chunk or process at a time. But when we talk about this here, these first two, we are really talking about the memory address widths. So how many little pieces of spaces, right? Because when you think about what a computer has to do, how does it know where to put anything in memory? Well, it has to have an address space. It has to have basically a little tiny box to put the stuff into. Okay, so if I have 16 gigs, but I'm running a 32-bit system, how do I address the 16 gigs when I only have the possibility to address 4 gigs? You can't do it. And so in a 32-bit computer, if you put 8 gigs in there, you know, in other words, your board could take 8 gigs. That's, your OS is not going to use it. It's only using half of that because it can't address it. It can't address more. So then when you move to a 64-bit operating system, one of the things you get is I can now address 16 gigabytes of RAM because I can address 16 exabytes of RAM if I want to. This also plays into how the hard disk works because it's the same kind of principle. I have to temporarily store stuff in RAM. I have to permanently store stuff on a hard disk or an SSD. How can I address that? So you start dealing with a 32-bit, right? 4 gigs is really going to hit your capacity. You can't address any more space for your storage. So it doesn't matter if you got more, you can't address it. Where on a 64-bit, right, you can. That's why this becomes a confusion to people, because it does deal with how big is my data path? How much data can I chunk or process at a time? And how much memory can I address at a time? So that's really what you're dealing with. A computer with an architecture of 64-bit really refers to the fact that the processor and the data paths and the integer size, that's processor stuff, and the memory address is all 64-bit. You're not saying, I've got a 64-bit processor so I can chunk more, but I don't have a 64-bit address. No, we did all of it 64. We can deal with that. Now, again, what you need to remember from this is when you go out and get stuff, I actually, probably in 3 years, this portion of the video will be gone because when you go out and download something, you need to know x64 is how we look at, oh, this is a 64-bit program or application. I've never actually seen it looking like that, but it's usually listed as an x64. And 32-bit is usually listed as an x86, which is basically 32-bit, right? This is the instruction set that we talked about. And so as we move forward, this is going to drop off because there won't be any computers around that need to do that anymore. And all the software will be updated. And that's kind of the thing. What's the last thing here, a computer with 32-bit processor can only run 32-bit operating system. And that means 32-bit software. However, a computer that's a 64-bit processor can run both. And so a lot of what we see here out on the downloads, like I need to download this or that, but it says the only download it has is for x86. What should I do? Well, that's okay. Your processor will be able to run it. And as they update the software, then the 32-bit option will fall off and they won't update that anymore, right? They're like, oh, we don't want to do that because everybody's got a 64-bit processor. That's what I mean. And, you know, 4 years from now, this won't be a part of it. Won't have to talk about it because nobody will be seeing it. All right, and then you need to understand that, of course, theoretically, there's a lot more that goes into performance. But if you took same type of system with everything and it's 32-bit, and then a same type of system with everything and it's 64-bit, because you can chunk twice as much or process twice as much than 32-bit, then you are twice as fast, basically. And again, that's theoretical. And the reason it's theoretical is because there's all sorts of things that go into giving us the performance that we have, not just the data paths and the processors. That's why I said if everything was equal except for the 32-bit and 64, the 64-bit is going to be faster. So that's the advantages of 64-bit as we're moving to that. It deals with storage, RAM, and how fast it can process because of upping the data widths on everything. And the other thing I wanted to share with you is this little graphic that shows a layer of an OS. This is a very popular way to look at it and understand that way down here in layer 1, you're dealing with the drivers, with providing software interface for how to use the hardware, realizing that there's a ton of drivers on every system, because how do you deal with the CPU? How do you deal with the RAM? How do you deal with everything, right? You have to have these drivers that push or make the hardware work. And then you have CPU scheduling. That's the next thing. Like, what is the CPU going to be doing at any one time? And then memory management, where can we put stuff in memory? This is a good thing that the OS has picked up on and done, because lots of times programmers will step on each other if they're allowed to do it. You can't think of all the billions of ways that something couldn't be stored. And so often a programmer would write something that would overwrite somebody else's program. Some hacking happens that way. So you have the OS deal with it. The OS says, no, you can use this. No, you can use that. You two stay out of each other's stuff. So that's the memory management. And then the process management. Those are all the things that are working in the background and managing what needs attention and when will it get it and that kind of thing. The IO buffer, meaning the input output. We don't really think about that, but that is, you know, a small portion of RAM that's used to send data in and out on a network, in and out on your mouse, anything that needs to have that regulated traffic to some device or to some other service. And then finally, your user programs, finally Chrome, Word, Safari, whatever you happen to be running up here in layer 6 to use your programs. And I think that helps identify like how or what's the most important to the operating system by using these layers, and understanding this helps you understand why certain computer crashes are worse than others. A crash here is not the same thing as a crash here. And quite often when somebody says my computer's crashing, then I ask a few questions to try to identify what layer this is happening at, because then the approach is different. All right, thanks for watching. We'll talk to you later.